Sliding window, day 3. Let's begin. Longest repeating character replacement. This is a medium level. You are given a string S and an integer K. You can choose any character of the string and change it to any other uppercase English letter. You can perform this. Sliding window. You can. I feel like the font is very small. Okay, you can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operation. Okay. 2. Replace the first A's with B's or vice versa. Return the length of the longest substring containing the same letter you can get after performing the above operations. Length of the longest substring containing the same letter. Four is the length of the longest substring that we can get, and it contains the same letter. Okay. Replace this A and this A with B, and then we have B, 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 B. Right. At most k times. So we have A, B, 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 A. So what if I replace this with A? Now I have 1, 2, 3, 4 A's. Replace the one A in the middle with B. This A with B and form A, B, 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 B. Okay. Okay, someone provided this nice description. First, if you start from beginning, first character of the string, do you mean you want to? I hope it's not a solution. I want. Is there a better description? Is there a better description that explains the problem well? Okay, explain this problem better. We are given a string. You can change at most k characters. In first example, the k was 2, so we can change at most 2 characters to any uppercase. But why would we change it to any? So maybe we'll keep some kind of count. For example, here we have 2 A's, 2 B's, so that's easy to choose. Whatever we have max of A, so let's make all the strings A at the end. But no, we need a substring. So we don't need to return a substring. So we don't need to create a substring from here. So after doing what is maxi, after that, what is maximum length substring? What is the maximum length substring where all characters are the same? What is the maximum? Window size, most frequent characters. We want the longest window where most frequent character count. In any substring, the most frequent character. So the remaining characters, window minus. Window size. If the most frequent character appears 3 times, then the remaining character is equal to window size minus 3. Those are the ones we need to replace. Okay. A B A B1. Window size is 4. Most frequent 3. Window size most frequent 3. Need to replace this. I think most frequent. These three need to replace. We don't try every character. Keep track of the frequency of so much. Keep track of frequency of characters. Maximum frequency inside window. Yeah. Okay. Keep track of the frequency. So we're gonna have a window. And we'll keep track of the maximum frequency inside the window. We want a substring in which every character is same. So it's my okay. I guess I'm gonna, well, like we do in every sliding window problem. I'm gonna create a end 0, create a begin at 0, while end is smaller than s length. I'm gonna need a map also. Map is equal to mutable map of character and int initially, let's say my window, initially only A is the part of the window. Okay. Frequency. A B A. Okay. We want the longest window where window size minus is smaller than or equal to k. Window size. If the most frequent character appears max times. maybe I don't need to pre-create my map for this one. As I'm encountering the characters, as I'm visiting, as I'm visiting through the, as I'm visiting. Yeah. We have 1A, B to B. Window size is 4. Most frequent is 3. Okay. I think I've got it. We try bigger window. APP. Size is 6. Most frequent is 3. Need to replace. Okay. So yeah, we don't. I don't know. I don't think. Do we need 2 pointers? Yes. What should? When should I? When should I stop my end pointer? Okay, so word and character is end. Map. Let's add this to map. We can say, well, is equal to map dot get or default and character. Wait. So let's see. To B is also to. We can get the maximum from this A, B, and then there are 4A's. I'm trying to think, what if we pre-calculated the frequency map 1 to 3. There are 3B's and 4A's. From this we can get we can get I can get my max frequency. Window size. So I move my A3, A2, P2, A1, B. Okay. When will I stop my monitor? When will I A, P. When will I move my begin point? Window size is 1. Here window size is 1. 1. Max frequency 4. I haven't understood this. Most frequent. Most frequent. What is the most frequent character within my current window? I don't need a character, I just need a number. The most frequent character within my current window. Let's see 0 plus 1 if map dot end character. Let's define most frequent here, or most frequent initially set to 0. Most frequent is equal to max of most frequent and okay. Now I need to check a a2, my window size is 2, my most frequent is 2, then my window size is 3, and my most frequent character is still 2. I mean, my most frequent is 2. Now I need what I need to do is what is my k at this point? So 3 minus 2, that's 1. That's 1. Or max or result, let's say result set to 0. I can say if my end minus begin this is my window size, if my end plus, let's move minus my most frequent, if it's smaller than or equal to k, when will it become greater than a? Just saying that, okay, this is my window size, it's 3, so, and in this window size there are 2 A's and 1 B, that means there is one most frequent. Can this be my, is length 3 be my, can this substring be my longest substring? Yeah, it's possible. Okay, because in this substring we only need to change in this substring of size 3 we only need to change one character, and we can do that because our k is 1. Then what I can do is then I can update my max or result, right? Result, update it to what? No. Let's keep it to the size of the current substring. Okay. There is still more characters in the string, so I continue looking forward. There is one more. Now my string size is 4. I mean my window size is 4. There are 3 A's and 1 B. That's 4. In this window, I only need to change one character to make it the longest. Can I change that character? Do I have the capacity? Is my K? Yes, K is 1. You only need to change 1. So yeah, we update our result. Okay, so what's next? Now my window size is 5. Most frequent character in this is well, A 3. There are 3 A's in this window, 2 B's. So 5 minus 3. That means I need to change 2 characters in this string, in this substring, to make it longest substring. Can I do that? Can I change 2 characters? No, I can't, because the K is 1. All right. If that's the case, then I can, well, if I can't update my result, then I move my other pointer, that is begin, right? So now I'm considering this substring. Considering this substring. And instead of 0 0 minus is smaller than, actually I need max of result, and I update my else, update my begin. Return result. Shoot, if I slide my window, I also need to decrease that frequency from this map, right? That's important, because yeah, that character is no longer in my string, is no longer in my map. Begin character is s begin if let's copy this, let's get that, and -1. begin character, begin character, begin character. All right, all right, all right. Output 4 expected, output 5 expected 4, output 4, output 3 expected 4. All right. Okay, what's my print end and begin? Begin and end. My window size basically. Zero 1, 0 2, 0 3, and 0 4. Zero 1, 0 2, 0 3, 0 4, 0 5. 1 0 1 2 3 4 5. Okay, this is the longest it considered, but that's not right. In this window there are 3 A's, 3 B's. 3 A's, 3 B's. So that means 5. 3 twice. This is not right, because most frequent value can become a really high number, and here maybe I need to reset my most frequent. Well, if I did not take the above route, if it did not go into this case, then that means should I like reset it to 0? Oh no, it didn't change anything. Okay, fine. Let's read something. First, if you start from the beginning, first character of string, intuitively know that we want to keep looking down the string until there are k characters that are different from most. This is expanding until it's not valid anymore. This means that moving the right pointer to the right one by one length of the substring. Okay, we monitor the condition max count. Simply we increment its count and check if it's greater than max count. If at this point we have a window from max count plus k characters in it, we know we can't keep expanding the window since there are already k characters different from our most popular one. So what do? We just slide the entire window down. Why? Slide the entire window down because the window represents our best answer so far. Anything less than this window we don't care about. No, we are trying to find the largest. We see a new character attend that to the count array. We also decrement the at this point we only need to know whether the total count of new character attend. If any new characters count exceed the max count, we have found a character in the current window that is even more popular for this. Just slide the window down, you're basically saying I have a window of length 4 where 2 of the characters were same, but more characters that are same. So maybe I need to change this most frequent to some kind of data structure. For example, when I drop a character from my string, this can still hold the value of that character as being the most frequent. And if I just set it to 0, that's also not correct. Yeah, so this is, I feel like this is the wrong part here. Zero 01, 02, 04 in the first example. K is 2. Look, we got the largest window. So why is my answer 3? Uh, and minus begin, that's 4. Minus most frequent. What was the most frequent character at this point? What was most frequent character at this point? Most frequent. 1. 3 minus 0. 0. 3 minus 0. Minus 2. 0, 1, 2, 3. 2. 3 minus 2 is smaller than or equal to. Oh. Okay, time to look up. Time to look the solution. Hash an array character at. Okay, we are filling the my frequency data structure, and then we're checking for the max frequency changes. Right minus left plus 1 minus frequency 1. Right minus left plus 1. Left. Hmm. The idea here to find the window. Whenever I satisfy this condition. Most frequent character count. Most frequent count plus 1. All right. It was a good problem. Yeah, so this was another substring problem we did today. I really need to revise the first two problems. Minimum substring window and finding all the n-grams in the substring. I don't remember the problem, and I will do that next week. And with that, I have one more problem, but the odd problem is gonna take time. So yeah, I'll do this one also next week. Okay, bye bye.